Good afternoon, everyone. It's an honor to welcome you to this critical discussion at the Linus Foundation Energy Summit 2024. So my name is Chris Xie. I'm the head of open source strategy at Futurewei, and also chair for the ORES working group at Energy. So as a strategist, my focus is on identifying the future trends and charting the directions for our industry. So climate change has presented profound challenges and unprecedented opportunities for innovation. So the recent advancements in generative AI have only amplified our energy demands, exacerbating environmental impacts. So Forbes reports that by the end of 2024, the NVIDIA H100 GPUs will consume more power than all the households in Phoenix, Arizona. So additionally, the average AI data center's water cooling requirements are equivalent to the annual water usage of 2 million US households. So the recent Hurricane Beryl incident is a stark reminder. It's a stark reminder of our grid power system vulnerabilities. Nearly 800,000 Houston residents endured power outages for almost a week. Facing extreme heat, the hurricane's 100 miles per hour wind caused power transformers to explode, utility towers to collapse, and left about 1 million customers without power. Tragically, at least 3 lives were lost due to the heat exposure. So this disaster highlights the inherent weakness of our centralized grid system. To address challenges of this magnitude, we must fundamentally rethink our approach to energy production and also consumption. This is where open renewable energy systems initiative comes into play. So ORES advocates for the local production and consumption of energy, democratizing the power generation in partnerships with the utilities and the grid operators to make it more resilient and accessible. The vision is that ORES-compliant equipment can be built or purchased easily and affordably, and enabling communities and individuals to directly contribute to making the grid supply more robust and resilient. So had Houston implemented ORES across households, the impact of the disaster could have been significantly mitigated. The utilities would not have to bear the full burden of recovery. So the restoration power would have been faster, and most importantly, life could have been saved. So today we have gathered an exceptional panelist to delve into these issues. So we will explore the current energy demands driven by energy emerging technologies, and the vision and the mission of ORES for creating a resilient and standardized energy ecosystem, and its role in enhancing grid health and optimization. So we will also discuss the key characteristics of the ORES system, the influence of governmental policy on renewable energy, and the collaborative opportunities within the ORES working group. So our format today is interactive. Each panelist will share insights through their prepared slides, and followed by an open floor Q&A session. So without further ado, let's start by introducing our distinguished panelists. We will start from Tony. Introduction.
Would you like me to introduce myself?
Yes.
Sure, yeah. Tony Shannon is my name. I work in the Government of Ireland with the Chief Information Officer looking after digital services for the Government of Ireland.
Thank you.
Hi, Savannah Goodman. I lead the team at Google that's incubating and developing data and software solutions to help us achieve our net zero and 24/7 carbon-free energy goals by 2030. And some of the solutions we're looking at are ones that we can support broader grid decarbonization, and we do see, the potential for distributed energy resources for that. So excited to be here.
Thank you. Karl?
I'm Karl. I have about 20 years firmware engineer background. So from 2022, we founded a startup, mostly device manufacturer. We develop a hybrid inverter or converter, cascaded power conversion system. Actually, it's a modular multi-level converter for ORES. ORES, we are working on an open standard and disaggregated solution. It's kind of DIY solution, so it will benefit manufacturer and customer, residential users.
Thank you, Karl. So what is ORES? Why ORES? ORES, Open Renewable Energy Systems. So we have a GitHub, I just got the definition of ORES from GitHub. It is a specification that describes the standard components of a renewable energy system, including its standard architecture, API, and protocols. So the key words are specification, standardized architecture, APIs, and system-wise, we wanted to plug and play. And why we want to do this? Because if you look at the right now renewable energy system, start from the residential solution point of view. If you install Tesla, for example, firstly, it is very cost prohibitive. $50,000 for a total package, including $25,000 on the labor, licensing, installation, about $20,000 for equipment. So it is not reachable for many households. So that's why we're looking at solutions like make it open source, make it standard so that more and more people and vendors, by adopting this standard, can create more interoperable devices. Because there are most vendors providing such devices, the cost will go down. So that is more accessible to many people. We said make it plug and play, because right now, look at the installation cost of the systems such as Tesla's. You have to change the electrical panel of your house. You have to do many other, licensing permits and things like that. And so our approach is to, again, for the ORES, so how can we rethink about the solution? And that's one of the things we're thinking. Okay, if we make it easier for people, just plug it in, right? That's the vision. And certainly, to make it happen so simply for our customers or consumers, there's a lot of technology involved in enabling that kind of solution. So that's what ORES generally is. So we want to ask a question to Tony. So could you share with us the current government policies in terms of renewable energy in Ireland, and how ORES can help in that area of the world?
Sure, Chris. Yeah. So, as I answer that, let me just set the context a bit, just to reinforce why I'm here and I'm speaking about this. I mentioned that my responsibilities for digital services for the people of Ireland, but it would be remiss of me to be delivering digital services for the people without thinking of the impact on the planet. And so I talk a lot about our challenges in terms of people and planet. And we know that we're trying to do a lot of transformative work in Europe at a European level in terms of this digital decade. For 2030, there's a lot on the line in terms of a lot of expectations to deliver better public services at this time. There's a lot of reliance now on the state to get more involved in people's lives. But Europe also recognizes this isn't just a decade of digital, this is a decade of green. So we need to do a lot this decade to actually address people's needs and the planet's needs. This is, I say it when I speak a lot, this is a decade that matters. There's a lot on the line this decade. And so what we're trying to do, if you like, is do two things, digital and green. And what Ireland is doing, like every other country, is trying to shift away from being carbon intensive in its production of production of energy, I should say. We produce about 40% of our energy with renewables at the moment. The target was 70%, is now 80% by the end of the decade. But we're struggling to meet some of that. And some of that is, my understanding, is that some of that is the difficulty, for instance, in trying to connect in renewables to the grid and so on. It's not as easy as it should be. And I think that represents, for me, a pattern that I've seen elsewhere in other industries, which is that what we have is a big and important industry in the energy sector, but it's not moving that fast. It's not moving to meet the needs of the times. It's a fairly top-down industry made of big players who all mean well, but they're not moving quickly enough to embrace the renewable revolution that is upon us. So I do know that it's difficult for people at a community level in Ireland to connect into the grid. So what does that say? It says that should we wait for top-down change of the grid and the energy sector, or is there a case for change here around renewable, or a refreshment, refactoring of the whole sector from the bottom up? And I think that's what ORES represents for us and for me, and the reason I'm here today, which is that if we get this right, what it talks about is being able to plug in your renewable energy, production or consumption, hardware into a plug-and-play approach, as you say, Chris, in a way that can scale from a local level at a village in Ireland to a town to the city and nationally. And I think that's why it's of interest to Ireland, and that's one of the reasons that I'm here today.
Thank you, Tony. That's very inspiring. And a question for Savannah. So, what are the key challenges? What are the key challenges that Google faces, right, in terms of renewable energy systems, and how ORES can play a part in that transition?
Yeah, so traditionally Google has really focused on procuring what we call front-of-the-meter, large-scale, utility-scale renewables, and we're still doing that. That's still obviously a very core part of meeting our goals. But as we know, there's a lot of constraints in the grid, and we're not bringing on clean energy fast enough to meet the growing demand across multiple sectors. So with the growing data centers, but also electrification, industrials, that kind of thing. And so with that in mind, Google is trying to seek creative alternative solutions that can still help bring resilience to the grid, but also do that in a clean way. So virtual power plants have been, I feel like, a hot topic on and off for a while, and it's back on. And what we are really focused on is actually less so on the hardware itself, but the connection to the market. And what we've seen is that the way that these distributed energy resources connect to the grid, it's very inconsistent. The market signals are not valuable enough. Chris, you were talking about the cost. A lot of times we can offset some of the cost of these systems by having them participate in the markets. But in order to do that, you have to have the right market signals that are valuing, that behind-the-meter flexibility in the right way. And so, we're doing demand response now with our data centers to help offset the peak capacity and to help bring resilience to the system by reducing our loads during, grid very constrained times. But we want to do more. We think it's important that, we can have flexible loads across the industry, not just from large industrials like data centers or manufacturers.
Very interesting, because Google, the large technology companies, Microsoft, Amazon, these are, as I mentioned, are huge energy consumers, but also as well as the producers. So that's where you mentioned about demand response, how this large system can help with the grid. At the same time, you also stressed about the importance of distributed energy and that's where ORES can help play a part in that area. Thank you. Karl, for equipment manufacturers, how does the equipment manufacturer support a plug-and-play ORES solution that empower anyone to build their own ORES systems?
Next page, please.
Yes.
Let me talk a little bit about the reference implementation for the ORES architecture, specification, and standardization. So with residential house, we have solar panel, we have microinverter, we have storage, we have energy storage systems, and also we have the AC bus. AC bus actually is the panel. Also we have the consumption, like a conditioner, of course, EV charger. So this is the scope we are creating the prototyping for the reference implementation. With this prototyping, we have a microinverter and hybrid inverter and battery with BMS. And also we are going to integrate innovation cascaded PCS. So this is mostly power plant. And also we have a control plane based Raspberry Pi based Linux. We run the home assistant on it. This is the brain. This is the controller of the house energy system. Right now, for the progress, we relatively have separate components up and running. Next, we are going to integrate them together. That's by the specification and the standard. Say, for example, for the inverter devices, we just add some adaptation, then it can work with the system. Also, we implement the EMS features. By home assistant, it's automation mechanisms. So answer your question, for each third-party vendors, as long as they implement the device adaptation with the system, then it can work together with this solution.
Thank you, Karl. So you can see here, there's use a lot of open source components. So that's really some kind of like a blueprint for people who want to do their own. But also at the device level, I think Karl will mention about like a third-party devices that are compliant to this ORES standard, then you have interoperable from different device vendors. Those devices, they can interoperate. And the purpose of the interoperability is not just like to have that connection so they can control it, but also it is a way for the vendors to have a mass deployment of their system, because now you get a broader use cases and application in the applications in the different in the same marketplace. So I think this you have another. That will be for the next one, but it is about the AC battery.
AC battery technology-based solution or product. Actually, internally, it's a MMC solution. Yeah, we can discuss more detail next.
Okay, sure. So if we go to the next question for Tony, what are some of the key challenges, like in Ireland, to adopt renewable energy systems? And how do you think ORES can help address those challenges?
Well, again, I'll just speak, from personal experience about what I know in the local area of people who are trying to get community energy projects up and running. They, with due respect to the grid operator, struggle, to kind of connect to one another and to the grid, etc. So we know it's kind of a laggard, if you like, or a drag on the acceleration of the renewable adoption. And so, we need to find a way to make it much easier. I mean, this is a problem that needs to be solved. We know that what you've just talked about, interoperability, is not a problem that's confined to the energy sector. It's a big problem that Europe has across all areas of its services in many ways. And interoperability, I've done quite a bit of work on in the past. And we had a related discussion, I think, earlier on about standards and how standards can and will help, and they will help. But standards are only as good as a reference implementation to start with, because a standard in a PDF doesn't really cut it, So what we're doing here with ORES, I think, is and Karl's work is the beginning of reference implementation of a plug-and-play architecture for renewable energy systems. That obviously is just a start of the transition that's needed, and we need to then try to iterate on that so that if there's a guy around the corner or a couple of neighbors that want to then begin to be part of this revolution in this movement, that they can begin to procure and to buy this kit and collaborate together. Right now you can't do that. It's just not possible to do that as far as I can see. There are too many barriers to actually plugging in and collaborating at a local level. And that shouldn't be a problem. We should try to solve that. And I think if we can in Ireland, there'd be a lot of interest in trying to mobilize behind that.
Mm-hmm, mm-hmm. And that's actually, you're talking about from the country level.
Yeah.
Right, and then that will natural to Savannah. From a business level, right, especially like a large company, multinationals, a little saving in energy will go a long way, right? Because you got so many deployments. The question is, how do you see these type of techniques or technologies will help large organizations like Google to address the energy crisis or energy challenge, the climate challenge?
Yeah, so as we know, Google is a global company. We have data centers in many different electricity markets, and as we know, all of those markets are very fragmented and tend to have their own sort of special snowflake rules. So for us, what we would really like to see is standards across what those markets look like, what are the ways you actually integrate, what are the, what is the value, and what are the requirements, and if we could have a more standardized approach right across our global portfolio, we can scale a lot faster. So that's, what's really most important for us to see. And yeah, I mean, I think we like I said, because of the existing grid constraints, especially in the US, like interconnection queue, we've started to actually invest already in some behind-the-meter or community solar projects where we're helping sponsor communities to do that, and then we'll, that they wouldn't be funded, right, otherwise without Google support. So we'd love to be able to do that more in more places in a more scalable way, but because of all the market fragmentation and the lack of sort of standards of how you do this with distributed energy resources, it's still very challenging.
See, that's where some of the enabling technologies can help play a role in addressing those challenges. And let's work out to Karl. That's doing the AC battery stuff. That's kind of like really innovative. Can you share more about that and
yes.
how that play part in the ORES system?
For the challenge for the new energy system, especially for hardware device vendor, firstly is the safety, secondly is the cost, thirdly is the efficiency. You know, this market is for hardware vendors is pretty challenging. So for ORES, we are doing some innovation with the device. We call it AC battery. It's everybody everybody knows battery is DC, right? But we call it AC because we can combine the power conversion, power electrics together with the battery. Also we can explain it from PCS perspective. So it's a cascaded or modular PCS. And from BMS, we can explain it. We extend the BMS features. It's not only the monitor and the protection, it can do the conversion, two-way conversion. It can do DC to AC, AC and DC. So this is the innovation we are doing. Why it is safe? Everybody knows the battery is not safe. Usually why? Or especially when overcharge or over discharge. That's because the inconsistent between battery modules. So with this technology, we can treat the different battery module, differently. If this battery module is strong, we discharge more and charge more. If it's weak, we can control it, discharge less or charge less. That's the reason it's safe. It's more safe than current technology. So second, why it costs low? Because usually the power PCS, they use IGBT. But for this technology, we use MOSFET. It's much cheaper. And also, we combine the PCS feature and the BMS feature together. That's why it costs less. Why it is more higher efficiency? Because it is the feature of the MOSFET this components compared with IGBT.
So it looks like this reminds me of the OCP story again. An open compute project where it is a specification that Facebook released, and specification for the server racks, and the server specification, the racks and the server, what's inside the server, the standard architecture. So with that standard architecture and specification, then many different vendors do that kind of, produce those kind of servers according to those spec. Facebook will procure more with less cost. And just single little change, like in your side here, AC battery, you change from the other material to this MOSFET, that drastically reduce the cost of the storage devices. That will be a huge saving, right? If Google down the road will procure many of those things, then not only reduce the capital expenditure, but also increase the ROI, and also the, for that matter, more renewable energy system will be utilized and reduce the help with the climate change. So with that, I want to open the floor to the audience to share your thoughts and your questions or to the panelists, and then we have some more of an interactive session. Yeah. You have a mic. You have a mic here. There's a question here. Yeah, here.
Yeah, first of all, So first of all, a nice initiative, because I think this is the first time I'm seeing something like this. I speak for myself. From the adaptation perspective, this is from a personal experience. So talking about consumers, because this is, I think, focused on more like bigger users like Google. So from consumer perspective, from my personal example, I was talking to a battery supplier. They are, of course, very interested in the Netherlands because we have a congestion problem to offer batteries to consumers. But they ask for energy contract with them, and they say if you move to a different supplier, then the support for battery management will be taken away. So then it will become your own responsibility. So what you are looking for here is a specific type of battery architecture. So unless there is a buy-in from the vendors to follow this, it will not really support the lower level of adoption, in my opinion. So what is your opinion on that?
So the question.
Well, I'm happy to have a go, just to start. I mean, so you know, you're talking, I guess, about the challenges in getting adoption of an approach like this across industry.
To the consumer level, not just the bigger user.
Sure, and I mean, here's an attempt to answer the question. If you remember the PC market, you know, before IBM standardized the PC and the motherboard, you know, there were different big mini frames, big frame computers. It was a different industry those days. And then IBM came up with the standard approach around the motherboard. And, you know, you began to get IBM PC clones, if you like, you know, that made them available to people, you know, personal people. I think we're very much at that early stage in this whole movement, where, sure, there'll be resistance from the incumbent suppliers, of course, you'd expect that. But that doesn't stop it from happening. What we need to do is obviously make a minimal viable product available, show it works, and begin to produce it. And it'll happen. So this change is going to happen. It's just a question of time in my mind. You just have to take the long view that this is just at the beginning of a movement and a transformation of the whole sector, and it has to start somewhere. So this is, and it's a big challenge, but by standardizing the interface perhaps around components at a household level, you know, between consumption and generation and storage, just that little motherboard idea, whatever that is, bit of hardware, bit of software, that's what's required to change the whole industry. And we get it out there and it starts working, the change will come. That would be my view.
Thank you, Tony.
I mean, I guess I would add, you know, I think it's not just the suppliers that need to adopt it. We have to do this in partnership with the grid operators and utilities. So, you know, I think in addition to the hardware specification, there's a need for this integration, you know, almost like a template contract, right? A template tariff or a template market construct. And certainly will require, you know, folks in this room who have been at the conference to get buy-in. And I think that's why the benefit of open source, right, is we can truly get contributions from different folks in the ecosystem.
Mm-hmm.
Thank you. I'd have another question that's more sort of like, we were talking about it from a more like technological perspective, but obviously it goes far beyond, like, we've got a government representative and like someone who's like potentially buying and saying like, we want to also have like behind the meter things, like looking at the community. Or I guess that's behind your words. Like, my question is, sort of looking at the community and with resilience in mind, you probably also want to target like installation of renewable energy in more vulnerable communities, which means like low capital expenditure possibilities. Like, have you, as part of ORES, like considered like how to, or like any kind of approach or tool to improve that capital expenditure part beyond just like the technological proposals? And maybe like a second part of that question, I guess specifically for Google, because you're the one representing buyers, as part of their purchasing strategy, would you potentially like give a premium, or at least like give special attention to like that kind of attributes, if we could track it back to the project, where we could also say that there was a stronger like social proposal out of it?
Oh, the question is, I guess the second part especially is, will Google have a preferential treatment to help elevate?
Yeah, I can answer the second part. I don't know if someone wanted to answer the first part, but yeah. So to answer that part of the question, yeah, we're absolutely looking at how we can have a social impact too. So some of the projects that we're doing are not even like solar generation, but actually energy efficiency, like weatherization, which can be really beneficial as well for the actual residents. And so we're looking to see, hey, could we help bring megawatts onto the grid by investing in these lower income communities who don't necessarily have the resources, but there's a lot of potential, right, capacity available. And with that, we can not only help weatherize their houses, we can reduce the the peak grid constraints, which is helpful for everyone.
I'll just try to tackle the first part of the question then in terms of low resource settings. So certainly, absolutely, that should be part of the ambition here, to be able to support low resource settings. And I know Martin, who isn't here today from Libra Solar, but we met last time we got together, is representing that kind of interest group, in Africa where they have a need for, low resource hardware, etc. But I think we need to be clear, to point that Savannah made earlier on, this shouldn't just be about off-grid stuff. This is about connecting to the big, getting the big operators on board as well. So it has to be what I would call a fractal solution that works at a local level where there's low resource, and it works at a city level or a national level too. That's the challenge in the architecture here, but there's no reason why that shouldn't be possible.
Yes. I would echo all these comments, but one thing I think in terms of adoption of ORES certification or ORES compliance equipment or devices, in general, as I mentioned in my opening statement, how long do we have to wait until more lives are having lost because of this climate change? Right, that will continue to drive this discussion, as you mentioned. Right, that's. When things go even worse and worse, then it's probably these are the solutions. It will be the right time for the industry to adopt. So we're just at Tony said, we're just at the beginning of this movement that requires people like us, our communities, to stand up and then to make a difference. So with that. Any other question? We have maybe one more question, or yeah. Okay, great. Well, thank you so much for participating, and thank you for the panelists. Thank you.